Hello, welcome to this tutorial. This is Chris. I'm here to introduce this interesting, hopefully you'll find it interesting tutorial, which is using two different programs. One is actually called processing language. I'll be running the processing interface. It's out of my Ubuntu Linux desktop. If you can install processing language, I believe at the website, I pull it up here real quick, it's processing.org. Let's see, under the download page, I believe they have a Windows installer as well as a Mac installer, and it also, they have installation for Linux as well. So while you can run it in Windows or Mac, you can certainly follow along in either one of those operating systems. I will be doing this out of Linux. For Linux users, this could be particularly useful in providing you with necessary information to interface between the two programs. So the topic of this tutorial is working with Bezier curves, and if you know anything about processing, and I'm going to go ahead and pull that up in Linux. Let's see here. I'm just using my console in Linux to do so. I've set up a special folder that is set up for my processing program. And I'll go ahead and just pull up my processing program. So in Linux, the command is the // processing, for instance, to run a program. I'll be doing a similar thing in launching Blender, although you can install it where you have a desktop icon in Linux. You'll want to have a console that's running side by side with your Blender program instance running at the same time. There's a reason for doing that, and that is that I haven't created any a write to file for data. So this is kind of one of those tutorials that, well, actually it's a kind of it's a way of interfacing between the two programs, but I haven't completely created the like Bezier editing functions, or like where you're importing the data from Blender to processing. I haven't created any scripts that does any sort of direct importation. So it does require a little bit of kind of handwork and copying and pasting data to do it. So this is kind of an interesting approach, but hopefully it kind of provides you with kind of like a way of working between the two programs, kind of a working knowledge in doing so. So I pulled up a program that I've written that actually takes, for instance, that Blender Bezier data and working between the two programs. And what I've done is I've conveniently copied and pasted the data from like the Blender console for Blender console outputs, data outputs, from like Bezier data that is in the Blender program application, and then I've just copied and pasted it into this program. So the data, the Bezier data does need to be in this type of format, at least for the program that I've written. I'll probably go through, just cover in a surface way some of the aspects of the program, what it's doing. But when you're importing, say, your own sort of custom data, if you were using something like my script, you'll want to have this data in this type of format, which is in a p-vector array format, with your main anchor points listed in the points array, p-vector array. Your you will have like for the Bezier data for each anchor point, a left and a right control point. So if you know anything about Bezier curves, and I'll go ahead and pull Wikipedia site on the Bezier curve. What processing works with is what's called a cubic Bezier curve, and with the cubic Bezier curve, there are four different points, four control points. They technically listed in processing, and I'll pull up the processing.org's reference on the Bezier curve here. Let's see, it's Bezier, I believe it's Bezier, well, there's the Bezier curve. Okay, Bezier vertex is what I wanted to pull up here. So that's one. I operate using the, my program operates using the Bezier vertex, and then I also do a Bezier call as well. So when you look at the Bezier function, this is a cubic Bezier curve function in processing that where they list the control points by anchor points or control points. They're in the Wikipedia's definition, or typically as it's defined mathematically, anchor points and control points are synonymous. The anchor points would correspond to, like in the Bezier curve, like the function itself, and I'll scroll right down here to the cubic Bezier curve. The cubic Bezier curve. This is the actual function. It's a parametric function where t ranges from parameters 0 to 1, and the control point p0 and p3 are anchor points. They correspond to anchor points in processing, as the way they've defined it. So that's just kind of an explanation there. So I'm going to go ahead and pull up my Blender application here. I'm going to close it out real quick so that I can demonstrate for Linux users how you can actually pull up your your Blender application, say if you've downloaded it from Blender Direct. So I actually put my file in my downloads directory, and I'm just going to go ahead and go to that here in just a second. And I actually did it under Blender 2.76. So I'm going to go ahead and copy this name, and then I'm going to change to that directory real quick. So I just went into, oops, it's saying there's no directory there. Oops, I think I pulled up the wrong terminal. So let me go ahead and do that. And yep, there we go. So gone ahead and gone into that. So we could see I just did a list of the programs in the directory, and there's an application there. Now that application is not actually linked to the control or the console environment, so that I could just type in, for instance, Blender. What I'll get is a message that says that it's not installed, but I can do a // command to launch the application. And so what that does is it not only launches from the console, but it also leaves me with a running console, so that if I do like Python scripts out of Blender, I can get print, read out commands from that. You can also do it through, let me see here. If you go in Blender under the Python Interactive Console, you can get readouts here, but the problem is that you won't be able to get read data if you're using, for instance, the text editor to do so. So that's the reason why I wanted this console, is so that I could get feedback, like data feedback, when I've called it written to the console that wouldn't necessarily be applied to the Python interactive console. If you're running in Windows, I believe there is under either the window up here or the help, there is an actual link that allows you to pull up a Python console, a separate a separate console window that'll give Blender data feedbacks. That will be important for the next script that I do run associated with the Bezier curve and Blender Python script, because that will actually read the control, all the control point datas that we need. So what I'm going to go ahead and do right now is delete this cube, and I'll go ahead and pull up, put in a Bezier curve here. So what we have for this curve is let's see, I'll just go into edit mode. We can see two different control points that are shown, or anchor points as they're called, and each anchor point has two control point datas, or two control points attached to that anchor point. So if I select this anchor point, though, it actually does not affect the basis of the curve if I change that along the direction of the line segment defined by these two control points. If I change that along that line, in the same direction, it will not affect the orientation of the curve. This control point will, and this control point will. So they actually correspond to the control points that are shown, for instance, in this Bezier curve. Going up here into this graphic, they're actually control points that would be like the P1 and P2 control points in the Bezier curve function data, or Bezier curve function. So what I'll do is I'll just go ahead and set up kind of an arbitrary, and I'll show you kind of some basic things working with the Bezier curve, interesting things. I'm going to go ahead and change this, flatten the curve to a two-dimensional state, and I'll go ahead and add a few points. So I just do Control and then right mouse button click, selecting one of the anchor points, and for some reason I'm not getting that to work. Oh, I'm sorry, left mouse button click, not right. So I can just kind of Control click, and then at some point I can connect, I can create, and my program, by the way, works with a connected or a closed Bezier loop. So you could modify the program, for instance, to work on an open basis, but I've done it on a closed basis. So what I've done is I've got these all these curves, or the points added to the curve. Now, if you want to smooth the curve out so that there's a little more continuity going from one anchor to the next, you can do so in Blender quite easily. And that is in resetting the handle type to say like an automatic, and it kind of smooths it out so that we have a more continuous looking curve. If I go into object mode, that's what the curve looks like. Now, once we have the curve, say, set to the type of where we like what we're seeing here, we can go ahead and gather the actual curve data. So what I'm going to do is go ahead and open up this other window. If you're unfamiliar with the Blender and doing so, you can kind of put your cursor up in this right corner that's shown, where you have the little cross that's shown, white cross, and then left mouse button click that, and then drag and hold it to the left. Once you've done that, then you can go into the text editor, and I have a handy script already written. It's actually very short, and you could write it in no time flat yourself if you wanted to do so. That is called Bezier Curve Data Read. So this is what the actual program that reads the curve data looks like. It's a very, very simple program. All you have to do is pull up the curve object data and then kind of run through the splines of it, and then gather from the points both the coordinate, the anchor point coordinate data, and then they list the control points that are associated with those anchors as handles. Those control points are either handle left or handle right, according to Blender's Python and console or programming interface. That's the actual call to it. I do a tuple conversion outside of Blender's native vector, because Blender has the data written as their native. I think it's a 3-tuple vector or three-dimensional vector. So I've just converted it to a tuple, which is just kind of like data that's read in and we'll see it in just a bit here when I run the script. So once you have the script pulled up, all you have to do is just click Run Script, and then we just go to the console that we have, and we can see 3 outputs, nice outputs that have been written here. Each of these outputs corresponds to the container containing the left, or actually the anchor points. That's the first one. The left control points associated to each anchor, and it's given array position, and then the right control set of control points. So we'll have to separately copy and paste these. I do use or do recommend using some sort of text editor program that has some sort of, and in Linux it's called, we can use something like, what is it called here? It's just called, I think, text editor is what it's called. But anyways, we can paste the data into, for instance, that text editor. If you have Windows, you can probably do the same thing. We'll need to change the brace, though, for how the data has been stored here, so that we can copy and paste it into the program that we have going here. So the one thing that I do use that'll make it nice and easy, because you may have Bezier curves that have a lot of that may, for instance, have a lot of control points, and if you're trying to convert the container, when you're copying and pasting it, say, into a program, that's what I basically do here. Is you can you'll have to put in this new p vector call here in defining, setting it up for the processing program script, at least the one that I've written. So in doing that, you can actually, and this is something that I've done before, it's an easy function. You can use a find and replace. So what you do is you just search for instance, the right parentheses brace, and what you'll want to replace it with is new p vector, left brace, or left parentheses, I believe, and then just replace that with new p vector in the same thing, and then we'll just click replace all, and conveniently, lo and behold, it'll just repopulate each and every instance that it finds that right brace, and it'll just put in that in that word string. So that find and replace will make it convenient. For instance, if you were working with 1,000 or 100,000 points, you can easily use the find replace function, so that you don't have to literally copy and paste new p vector in front of the right brace or the left brace, or the left parentheses each time you see that. So once you have that, once you have that done, all you have to do is just go ahead and copy and paste what you have here and just put it in, for instance, your points, where it says the points, and whoops, and there we have it. Now you probably want to do with it may be easier to read it if you actually have some sort of control return. Unfortunately, I don't have anything. You may be able to go ahead and figure out some sort of function that allows you to make this a little more readable. It's not necessary that you have to hit return, for instance, to make it the data more explicitly readable here. But I do it so that you can at least read it as it's shown. So again, what we'll do is same thing procedurally for each of these, just each of these data containers, and we'll go ahead and put that in there. And I'll just paste that, and then I'll just call up the find and replace. A lot of these text editor programs, by the way, virtually all of them, to my knowledge, have some sort of will usually have some sort of like find and replace function that allows you to easily do what I just did there. So I'm just going to copy and paste these, put these into my Python or my processing script. I'm just going to avoid hitting the return and setting that part up since it's not exactly necessary, as I've stated before. And we'll get the next and the last set of control points here. You'll want to pay attention, make sure that you're going and grabbing that data properly there. So once we have that, see, find and replace all, close that out to replace these braces, and once we have these replaced, then we'll just go ahead and put this apply this to processing. Okay, so that is it. Once we have that, then you should be able to just run the script, for instance, and there we have it. I have a path tracing program that creates a little Bezier curve that runs along the curve path itself. So if we kind of compare that with the original, so we can see that we should have a similar, this may be actually rotated because of processing, the way that their data works. It will do that, but in any event, that demonstrates the application of the tutorial. Now I'll just go into a brief explanation of my Bezier program, what it's exactly doing here. So there are two parts of it. I actually searched in the processing.org, their reference site, to see if I could figure out how to access, like for when you do the Bezier function, graphics drawing, how to access like the individual points data on the parametric curve. But unfortunately, I didn't see anything that was stated on how to access that data. So because the Bezier cubic function is such a simple, it's a really small, simple function, I just went and put in the function itself, and that's actually stated with this call here. And I use the p-vector processing p-vector class to make the cubic function to make it easier in terms of working with the data like in a p-vector or a vector type class format. So we can see that is all constructed there. If you want to, like I stated before in referencing this Bezier curve, I actually use this website data and the Bezier curve, and then went to the cubic Bezier curves function call. This P0, P1, P2, P3, those are all assumed in a like a vector or some sort of three-dimensional tuple format. So it's and then we have the T parameter, which runs stepwise from 0 to 1. So when I actually did the drawing, all you had to do is translate these control points or anchor and control points to processing, and I figured that all out here. I won't go into an in-depth explanation, but you do have to align the left associated with each anchor. It's necessary corresponding control point for the curve, and the similar deal with the other anchor point. And then I use the Bezier vertex in doing so. So sequentially, when you're working with like a Bezier vertex, it just goes from one anchor point to the next, to the next, to the next, and whatever anchor point that you were last left off, or that you were last at, would be assumed as like the left, like on this curve up here, the graphic of the curve. The last vertex that you're working on with the Bezier vertex would be considered the P0 anchor point. So the new vertex that you enter, on the other hand, the new anchor point that you enter is considered the P3 vertex in the Bezier function call. And then you have the P1 and P2 control points that are input with that call. So that is done right in this section here, with the reference to the left set of left points, which are the left control points, and then the right points, right control points associated with a given anchor. So once you have that, that's basically how you would draw, for instance, and I'll change so that we can see the actual curve. I have show track as the function here. You can change this to true if you want to see the trace that is shown for that given curve. And so with that track, that's actually given that is drawn by the Bezier functions in processing. So the other thing, though, when I was wanting to create a track animation, is that I needed to actually know on a given on the curve all the possible sets of points between these anchor points on the Bezier curve. So I actually did a step computation, and that was done at the outset of the setup call here. I did a step computation, and that's given with the user specified parameter t step, or you can specify the degree of the time step and that or steps, small steps that would be taken going from 0 to 1. So I made that, went and computed all the curve points, and then added that to a given curve points array list, p-vector curve points array list that has all those curve point data input to it. So that's kind of important, because then we can apply constraint functions, which is what I did in drawing like path tracing along the curve itself. So those step points that are running here, and I'll just go down, scroll down a little bit into the program. Let's see here. So it's while we're at a given A step. And the A step actually controls like where we draw at the beginning of our little tiny Bezier curve segment that's tracing along the big curve that we're constraining that little Bezier curve segment on that curve. That A step is animation step is where we start drawing the curve at whatever animation step point on the curve it's at. So I arbitrarily set it to this A step I, which can be modified as we increase the length of the curve to whatever desire that we want to for the path tracing. And so in drawing it, all I did was just created a little loop that constrains the curve points constrains to the curve using the known curve points on the big Bezier curve that we have. So that kind of, hopefully that makes a little bit of sense to you. If not, the program is available. You're welcome to study it in depth to understand exactly what's going on with it. Hopefully you'll understand it in time. If you don't, I didn't want to get into a really lengthy discussion about it, what's going on here, but in any event, this is where you import your data. You'll just want to use the kind of step process that I applied, but that's basically how you can use Blender as a Bezier curve editor, and then importing the data from Blender to processing. I know processing does have also has a Bezier curve editor, supposedly with a data importation. I was not able to get it to work with Linux at the moment for whatever reasons. I'm not exactly certain, but I was curious to see if I could do it, use Blender as a curve editor, and lo and behold, it does work. So that completes this tutorial. Thank you for listening in there.